6, not the way I wrote it there. So our final velocities. I find this the simplest method. Definitely less writing. But you need to understand what you're doing when you're doing it. So a couple key things. Initial velocity, you have to figure out what the what you need to do to shift. You shift it, flip the signs, unshift, and end up with the final answer. All right, so we now have 3 methods. Method number 1, you'll end up with a quadrant. You'll have conservation of momentum, conservation of energy. You'll have a momentum, you'll end up with a quadratic. Method number 2, you use conservation of momentum, and then the combination of the two, the relative speed of approach equals relative speed of recession. And then method number 3, shifting out of that time frame and then back into it at the end. I do not care which method you want. I will tell you, the next test that requires a calculator will have a problem that is going to have a one-dimensional, perfectly elastic collision. So, I'm going to give you a problem, and I want you to work on it, and come up with the right answer, of course. I guess a 4th method would be just complete trial and error, but I don't recommend that one. All right, so 410.81. Going in the same direction. Let me make sure I did not flip the numbers around. So I got 4 kilogram and 8 kilogram. One's going 10 meters a second, the other's going 1, both to the right. Okay. Please work on it. Pick a method, know how to do it. All right. We resume after much rejoicing and merriment. All right, so total momentum, so method 1. I know that's 40 units of momentum, and that's 8. Take that in the positive direction. So 48 is equal to 4 times C plus 8 times D. Using the notation I used before for C and D, or the representation. Let's make it formal. C equals V4 final, D equals 8 final. The other equation is, it's it's a one-dimensional, perfectly elastic collision. So we got our kinetic energy, so I got 1/2 times 4 times 10 squared, plus 1/2 times 8 times 1 squared, equals 1/2 times 4 c squared plus 1/2 8d squared. Questions on where these come from? All right, so that's 200 plus 4 equals 2c squared plus 4d squared. 204 is equal to 2c squared plus 4d squared. We can divide by 2 just to simplify it. So I got 102 is equal to c squared plus 2d squared. This equation up here, it works out nicely. I can divide by 4 and get rid of some stuff. So 12 is equal to c plus 2d. Doesn't always work out that nicely, as we saw earlier. And I'm going to solve for c and plug into here. So from this equation, I see that c is equal to 12 minus 2d. Plug in. So 102 is equal to 12 minus 2d squared plus 2d squared. 144 plus 48d plus 4 squared, 4d squared plus 2d squared. It's a quadratic equation. Quadratic formula is probably the simplest method here, although this would factor. But we end up with 0 is equal to 6d squared plus 48d plus 42. Oh, this does work out nicely. You can go to quadratic formula, or let's divide by 6. 0 equals d squared plus 8d plus 7. So d plus 1 times d plus 7. So d equals -1 or -7. Oh, something was off there. That's negative, negative, negative. And then plug it into our formula over here. C would be 12 minus 2, or 10. Or plug in that, you'd have 12 minus 14, or -2. That's the no collision solution. So we've done something right and tack on the units. Method 1. I know I started to zip through that, but take a deep breath here for me. Let you ask questions. Method 2. Well, we've already done some of the work, so we'll just start out with that one. We know we'll still be using this conservation of momentum equation here, which simplified down into 12 is equal to c plus 2d. And then we have 10 minus 1 is equal to d minus c. Whichever one, I'm going to subtract the velocities. In whatever order I subtract them in to begin with, I flip the order afterwards. Since I started with the 4 kilogram mass here, I'm going to start with the other mass on the afterwards. Therefore, 9 plus c equals d. Plug that in. 12 is equal to c plus 2 times 9 plus c. C plus 18 plus 2c. -6 is equal to 3c. C equals -2. And then plug into there, d is equal to 7. lo and behold, the same answer. Questions on this one? And then method 3. I need to figure out what is the zero momentum frame, or what, in essence, an object is zero momentum if it's not moving relative to the observer. So if I look at the combined mass after the collision as, if I'm going the same velocity as the combined mass afterwards, then it looks like it's not moving at all. So that's why it's the perfectly inelastic collision solution. So I have 48 is equal to my combined 12 V final. And so then we get into, I've got my 4 kilogram and my 8 kilogram. They're starting out at 10 and 1. I subtract 4, get 6 and negative 3. Which is sort of what you were doing, Michael, when at one of your solutions. You had a 6 and a positive 3. And so somehow you were doing this. Just wasn't quite sure how you were getting there. Then there's the collision. These change signs. And then shift back to the original frame. And we get 2 and 7. If you need more, I've got several videos going over each method. Or I have at least one video per method, so. You have additional supplemental material there. And again, there will be a question on the next calculator test with a one-dimensional perfectly elastic collision. And every year I say that, and every year when I look at the tests, I'm thinking, this person didn't take me seriously. Some do, but there's some who don't know how to solve the problem. Questions before we do a two-dimensional perfectly elastic collision? Or an imperfect collision? You have the look of that you're about to ask a question.
No questions. I'm just...
Okay. Patrick, you good? And that's all, you shake your head. So. All right, I'm gonna keep the same setup here. Let's do the imperfect, one-dimensional imperfect collision. And again, imperfect is a term that is not traditionally used, but all I'm saying is that it's a closed system, or close enough to a closed system, but we are going to lose kinetic energy. From a practical point of view, they're going to probably heat up a little bit. Now, what I have traditionally done is, not every year, but I say set up the equations. So in the collision, 10% loss of kinetic energy in the collision. We don't have the luxury of the techniques that we were using, but we set it up. Conservation of momentum. Again, collision, closed system, momentum is conserved. 48 is equal to 4c plus 8d. That same as before. But what would the other equation? I got two unknowns, so I have to have at least two equations, two independent equations. What would the second equation be, given this piece of information here?
Ki equals 0.9 kf.
So if Kf is 10, Ki is 9. What's wrong with this?
Would be flipped.
In what way?
0.9 Ki equals Kf.
Your final's gotta be less than your initial, there's a loss.
Right.
Whatever the initial is, it's 90% of that. So from 0.9 times 204? Oh,
I think
sorry,
it was,
on this board.
it was 204.
Okay, is equal to 1/2 4c squared plus 1/2 8d squared. So we've set up the two equations. When I'm talking about setting up the equations, I would not consider that this is a necessary step. You don't necessarily have to write it down, but if you just wrote those down, I would not consider that set. Because if you're doing it this way, then now I have 4 unknowns. Or I guess we could figure out out of that. We have 3 unknowns, so there needs to be another equation. And then you're destined to use the quadratic formula on this one unless the numbers happen to work out nicely like that did, and we can factor it. But it's just a math exercise at this point. We will get 2 answers. One of the answers will make sense, one of the answers won't, most likely. I guess potentially you could have 2 possible solutions. Actually, I don't know if that's true. But one of the solutions most likely is that the 4 kilogram mass is going to be having velocity that either 4 kilograms is still going to be going to the right, and 8 kilograms going to the left, or the 4 kilogram and the 8 kilogram are going in the same direction, but the 4 kilograms is traveling faster, so it travels through it. So that would be the solution to throw off to the side, let the jackals eat it. Questions here? All right, let's take a look at 2-dimensional problems. We're gonna keep that. I do have to give you some piece of information. So after the collision, if that's sort of the line of assault, after the collision, the 4 kilogram mass is driving off at some angle there. The 8 kilogram mass is traveling off at some angle there. Theta 4 and theta 8. And I do need to give one other piece of information here. Depends on how hard I want to make it. We'll just say that's 5 meters per second. To find the velocities afterwards, I know that a velocity is 2 pieces of information. It's magnitude and direction. So if I did not give this to you, I'd have the magnitude, direction, I'd have 4 unknowns, and I would need 4 equations. And so I have to give you some other bit in order to solve it, because just as is, if it's a perfectly elastic collision, you got three equations right there. So let's make it a perfectly elastic collision. What are the three equations? Feel free to just give one of them, just to get us rolling.
So in this situation, is the 4 kilogram block impacting the 8 kilogram block? or-
Yes. Yeah. 4 kilogram, if we wanted to add some type of reality to it. In the one-dimensional collision, the 4 kilogram, the center of mass of the 4 kilogram is gonna be dead on with the center of mass of the other one. This case, it'd be slightly off. Center of mass would be, say, lower than this, which would cause the 4 kilogram to shoot off that way, and the 8 kilogram to shoot off that way.
Well, the total momentum is still the same, right?
Yeah. Therefore,
We still have our 48 is equal to 4C plus 8D.
it's gonna be more complicated than that.
Do we split it into vector parts, or like dimensions, I and J?
You were worried about that. Patrick, your suggestion to bring in I hat and J hat, are you good with that, or do you want me to change it around?
That's fine.
Okay. So what are the two equations? And just for the sake of ease, we'll make that one C. That's D.
Are those vectors? C and D?
C and D are the magnitudes of
Okay.
the,
So it would be that times something.
okay. There's gonna be an equal sign in there too.